Hey y'all, I want to review what we learned in class today. We finally went over Euler paths and circuits. Sometimes Mr. Dietz calls them Euler. They mean the same thing, whatever you want to call them. So we have some examples here of graphs to look at. So this is 6, 7, and 8. Um, Question number 1 asks you, what is the degree of each vertex of the graph? So, just a suggestion. If you want to, if you when you're doing this and it doesn't give you like A, B, C, D, E, F, G, or if you just need to label paths, you could only circle ones that have odd degrees. That was a suggestion that Mr. Dietz gave us today during class. But here for the first one, graph number 6 that we're looking at, if we look at each of the vertices, we'll start with A. It has two lines coming out of it, or two edges coming out of it, so the degree is 2. So for B, the same thing, 2. C, however, you've got 1, 2, 3. Oh, I don't know where these went. They disappeared. Oh, what in the world? There it goes. Okay. D, it's 1, 2, 3. E is 1, 2. F, 1, 2. G, 1, 2. So you'll notice here that we have two odd vertices, C and D. So I'm going to circle those, C and D. Um, if we have two odd vertices and the rest are even, then you technically have what we are going to call an Euler path. Okay, so it has two odd vertices. I'm just going to put a V, and then you can have as many other even ones as possible. If you have one odd vertice, then you can't even draw that graph. That doesn't exist. If you have 0 odd vertices, that just naturally means that all the vertices are even, and you would have an Euler circuit. For total number of edges here, that means if you're not sure yet, I think of edges most of the time as lines. They don't always have to be a straight line. It could be like a curve or something. But for the purpose of counting, we have 1, 2, 3, 4, 5, 6, 7, 8. Life is so much easier in this unit if you have a highlighter. So the total number of edges is 8. Okay, let's look at number 7, graph number 7. So here for A, we have 1, 2, 3, 4, 5. So that's odd. B is 1, 2, 3, 4, 5, also odd. C is 1, 2, 3, 4, 5. Okay, so somebody asked a great question today in class. Technically, if I get to this point and I have more than two odd vertices, then I know that you can't. That this is neither an Euler path or an Euler circuit. So this is going to be neither. If it were to be asking that question, because we have more than two odd vertices. I'm going to finish counting though, just for the purpose of filling this out. You have 1, 2, 3. And then here you have 1, 2, 3, 4, 5, 6, 7, 8. At E. And here you have 1, 2, 3, 4. All right. For edges, this one gets a little crazy. Let's see. See, this is a good example of having curved lines and not straight ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So right here, you're going to have 15. Alrighty. And then for graph number 8, let's my face out of the way. So for graph number 8, we start at A. You have 1, 2, 3. Remember that loops count as 2 when we're counting our degrees. 3. B is 1, 2, 3. This is 1, 2, 3. Again, here we have more than 2 odd sets of vertices, so I know it can't be an Euler path or an Euler circuit. 1, 2, 3. All right, so for total number of edges, different color, we have 1. A loop does count as an edge. 2, 3, 4, 5, 6. So here you have 6 edges. That just gives you a basic overview of how to count the degree of each vertex of the graph and how to count the total number of edges of each of the graphs. I do want to make just a few points real quick, so I don't have to make a whole nother video today. But if we're talking about Euler paths and Euler circuits, an Euler circuit, there's a few kind of like rules that you have to have. You're going to have to start and end at the same vertex. Okay. And you have to, the degrees of all of your vertices have to be even. Okay. Those are some rules. You also cannot pass over an edge more than once. Like once you've gone down the line, you cannot come back to it. That is the kind of one of the opening activities we did in this unit. Mr. Dietz didn't tell you why you were doing it, but he asked you if you could start at any point, trace your way all around, hit every single edge or line in the graph, and not double back over the same one. So you cannot go back over an edge twice. It's a little bit different with an Euler path. You'll have 2 odd vertices and you have 2 odd vertices and you must start and end at an odd vertice. And end, I think I can actually write over here. Odd vertice. So that means that if you start at the 3 or the 5 vertice, then you must end at the other 3 or 5 or 7 or whatever the odd vertice is. And you're going to trace every single edge one time exactly in an Euler path. Hopefully that's helpful. Let me know if you have any questions at all.